Subscribe to this YouTube channel by clicking the subscription button below. For future webinars and online short courses, please visit our website at australianwaterschool.com.au. Welcome to this 93rd Australian Water School webinar brought to you by iSwarm. This outstanding webinar series engages leading thinkers in the water sector globally, and today it's no exception. Tyler Jansen from Jacobs will lead the discussion on realising the benefits of cloud computing. So glad to have you here today. My name's Trevor Pillar, National Partnerships Manager and Webinar Chair. And you can see on the screen in front of you there, tons of upcoming training. That's just the coming month or so. Every month we're doing the same. Go to their website. We'd love to have you join us for the free webinars on online courses. That'd be fantastic. Look at the spread of people around the globe. Thank you all for being with us. There you all are. Right now, let's get to the main game here. Tyler Jansen, so glad to have you join us there from sunny Seattle.
Yeah, I'm here in Seattle, Washington. It's been sunny today, but rainy the past 2 weeks. Right. Lots of flooding here.
All right. So good to have the water, but good to have the sun too, I imagine, where you are.
Yeah.
Tyler's a water resources engineer at Jacobs, based in Seattle, USA, specialising in flood risk management. Probably useful, very useful where you are. He works on a wide range of projects for federal, state, municipal and private clients around the globe. Holds a degree in civil engineering, water resources engineering from University of Texas at Austin, and has over 12 years experience with the modelling industry. What is it that sets you on this path? What drives you?
Yeah, well, Trevor, thanks for the introduction. And no, I really enjoy flood modeling, and I think what I really enjoy is doing it well and kind of doing it the right way and finding good tools to make it better. So I'm excited to share some of the tools that I have that I think make flood modeling a better system.
You'd be in good company today, I'd say. That's exactly where we're going. That's great, and everybody joining us today would have to be cheering that thought. We had some polls. Thanks everybody for answering those questions. That's great. We might just have a quick look at them. Are they coming up? There we go. Right. Any thoughts on that? What sector you're from? Mainly commercial consulting.
Yeah. So I see a lot of consultants here, which is I'm in a good company. It seems like.
Right.
Yeah, it's a mixed bag in terms of what folks have been doing so far with cloud technology. So I see a lot of folks that say yes, they are comfortable, but quite a few that also say they are not. And so I think this
evenly
will be
spread across the lot, isn't it?
Yeah, it really is. And so I think this will be helpful for those that are either maybes or no's. I hope this is informative, and for those of you that have yeses, hopefully you can contribute to the conversation as well.
Yeah, for sure. So that third question, cloud technology mainly. No.
Yeah, a lot of folks that have not used it. Well, that's then again, you're in the right spot. I think this is a good place to learn about some options for using cloud technology for processing data and not just storage.
And most today, of course, are involved with flood modelling. That's good. Most people are using HEC-RAS, quite a few TUFLOW with Swim and Flood Modeller. Yep. Yep.
Definitely some folks who don't have enough licenses in their organization, and some folks out there that could use more computational resources to meet their deadlines.
They've been really great questions. That's helped a lot, Tyler, wouldn't you say? Thanks so much for taking the time, everyone, to answer.
Yeah, absolutely. That helps ground me a bit and understand who I'm talking to. Sure.
Yeah, no, it's great. So, well, let's not waste any more time. We'll get straight into this. It's terrific. You're going to speak to us for 30 minutes or so. And look, if people have got questions on the way through, by all means, put them up there. We might find spots where Tyler will break the presentation and go to the questions. So don't hesitate. Write questions, write comments, discussion points up on the Q&A icon. That'd be fantastic. But right now, we're in your hands. Tyler, over to you.
Very good. Well, do you see my screen there, Trevor?
Very clear. Top.
Very good.
Really good.
Well, yeah, thank you, Trevor, again for the introduction. I am really excited to be here with the Australian Water School again. I think I was here about a year ago with a similar presentation, so it's good to be back. And thank you all for joining today. I hope you learned something. I hope this is intriguing to you, and look forward to the discussion afterwards. So, as Trevor said, today we're talking about cloud computing, especially as it relates to TUFLOW, HEC-RAS, and Flood Modeller models. We're looking at how it stacks up. So a bit about what we'll talk about. I'll go over fairly briefly what is the cloud and why we use it and how we use it for 2D flood modeling. I'll also talk about a product that we have out there called FloodCloud. And that is, FloodCloud is a product that enables flood models to run on the cloud fairly effortlessly. It's a pretty neat tool. I'll give you a demonstration of that tool and then go over a couple of case studies where we've actually applied FloodCloud on projects, and we've seen some substantial benefits to those projects due to FloodCloud. And then we'll have some time at the end for Q&A. So what is the cloud? Back to the poll, there is definitely some folks out there who have used the cloud and a lot of folks who haven't for processing. The cloud is a network of remote servers hosted on the internet to store, manage, and process data rather than just on a local server or your personal computer. And I think it's that last part, the process data, that I'm really going to be talking about here today. I think a lot of us are comfortable with the cloud as a place to store files. I think we use it to share photos. My 7-year-old, that's how he shares videos with his grandparents, is over the cloud. I think many of us in our work settings use the cloud as a place for file storage and collaboration with colleagues. But what we're really talking about here today is kind of the next level, which is using these remote network of servers to process data. And in this case, it's to process our flood modeling data and run our simulations for us. Some key benefits of the cloud as it relates to flood modeling is that it's flexible and it's on-demand computing availability. And when I say flexible, it allows you to quickly ramp up and ramp down. You pay for what you need. You only pay for what you use. So if you need one computer's worth of simulations one day and 1,000 computers worth of simulations the next day, the cloud can accommodate that. So it's truly scalable, which is one of the reasons that it's so helpful in our industry. It also does not have to be managed by end users. So when I say end users, I mean me and you. The cloud is being managed by professionals. There are folks at Amazon and Google and Microsoft that are all managing this, and they do a great job. And that really takes a load off of your shoulders and maybe your IT department's shoulders as well. So flood modeling in the cloud was really developed to enable modelers to unlock an opportunity gap that exists between how we have historically modeled and how we can model and how we should be modeling in the future. This gap consists of really 3 components. One is an increasing need for richer flood information by the public, by the governments, municipalities, and sometimes in my boss and your boss. And when I say richer flood information, I mean there's this need for probabilistic analysis and looking at a wider range of potential futures and looking at climate change and just running more scenarios. And all this takes a toll on our computational resources. At the same time, there's been just enormous progress in the IT space, especially in the cloud computing space. And so more and more is becoming possible each year. And then at the exact same time, there's an increasing demand for fast and efficient delivery. And so all 3 of these things really came together to lead to the development of flood modeling in the cloud. So why use cloud computing for 2D flood modeling? Well, the first reason I think is to improve your models. And so in this case, we're talking about TUFLOW, HEC-RAS, and Flood Modeller models. So imagine for a minute, for the modelers out there, that you can run unlimited calibration simulations. You're no longer hampered by computational speed and time, and you can run as many as you want. So you have the freedom to turn lots of knobs. You don't have to limit yourself to just a few, and you can achieve a better calibration of your model. Similarly, imagine if you had the ability to run unlimited validation simulations. So you can look at, instead of just validating to one event, you can validate to multiple events. Instead of validating to just one location, you can validate to multiple locations. And you can look at this from a variety of perspectives. Well, that's something that cloud computing enables us to do because it allows us to run more simulations in the same amount of time that we had historically. We can combine hydrology and hydraulics in ways we haven't before because we can test more combinations and run more simulations in the same amount of time. We can do better jobs at optimizing our parameters in our models, ultimately making for better models and better decisions. Another reason why I think we should be using cloud computing for flood modeling, for 2D modeling, is that we can run more scenarios and enable better decisions. So historically, I think many of us were used to running just a handful of simulations. You had a single base run for a single design event. Maybe it's the 1% annual chance event. And so you have one set of hydrology running through there. And then maybe you run 1 or 2 or 3 future alternatives. But more and more, we're being asked to run more simulations to enable these better decisions. So we look at multiple return periods. We look at multiple points in the future, or epochs. We look at climate change. We look at a range of climate change scenarios, maybe a low, medium, and high scenario for future conditions. We look at a variety of management options. And all of these things multiply against each other to mean that we need more and more simulations. So whereas historically we might have had a single or a handful of simulations, really quickly we need dozens, if not hundreds, of simulations to enable these decisions. So we're looking at a truer picture of flood risk. We're looking at spatially varying probability of flooding, spatially varying impacts of the flooding itself, these varieties of durations and a variety of risk attributed to our defenses. And so by running more simulations, we can better provide better information to decision makers to make these better decisions. Another reason why we want to use cloud computing for 2D modeling is to improve our understanding of model confidence. I think as modelers, most of us know that the inputs to our models, the parameterization is uncertain, that our flood defenses and our understanding of the terrain, our channel geometries, our channel and floodplain roughnesses, all of these have uncertainty associated with them. And maybe we set it at a single value, but we know that there's a range of values that could be represented or could represent our channel roughness, et cetera. And so, typically we'll do some sort of sensitivity analysis, but often I think we're limited by the number of simulations we can perform as part of that sensitivity analysis. And what cloud computing enables us to do is to run a much fuller, much more robust sensitivity analysis. We can quantify the variations in the outputs from our model relative to the uncertainty in the inputs of our models, and we can test that full space of all of that uncertainty. We can even run a full probabilistic analysis, including breaches of flood defenses. And then lastly, but I think maybe most importantly, a really good reason for using cloud computing for flood modeling is to access superior processing power to beat deadlines. I think most of us are more frequently under pressure of deadlines than maybe we were before. I feel like there's increased pressure to do things better and faster with more data and bigger models and more outputs. And cloud computing can help us get there. Another really big advantage of cloud computing is that it can free up scarce and costly licenses. So when you're running your simulations on the cloud, it's using the licenses on the cloud. It's not using your license that you have associated with your system. And so it frees you up to use your license to do higher value computing, to create new models or debug existing models, and to use that license for a much higher value than just running simulations. So FloodCloud makes this all a lot easier. But don't worry, there's still a huge need for modeling skills. None of us are out of jobs due to cloud computing. So I'd like to shift a little bit. I'd like to introduce FloodCloud, which is a software product that enables modeling in the cloud. It is a standalone piece of software. It provides an efficient way to run 2D simulations in the cloud. And I think, as we think about cloud computing, any of us could contact directly one of the major cloud providers, and we could set up to run any of our softwares, be it a flood model or something else, on the cloud. And really, it takes quite a bit of legwork to make that happen. It requires some technical expertise that I think many of us don't have. I know that I don't have. And so this FloodCloud product, this FloodCloud software, allows users like me and like you to easily run your simulations on the cloud with pretty much just the click of a single button. The FloodCloud system is compatible with multiple solvers, multiple engines, so HEC-RAS and TUFLOW, Flood Modeller, and soon to be SWIM. Within TUFLOW, it currently covers the TUFLOW Classic engine, but the HPC is coming. It's on its way. The cloud system uses a pay-as-you-go credit-based payment system. So you pre-purchase credits, and then as you run simulations on the cloud, it uses those credits based on the number of hours or how long your simulations run for. So the equivalent cost is about $3.30 Australian for a TUFLOW simulation hour and $2.60 for a HEC-RAS simulation hour. And again, that TUFLOW simulation hour, that includes the TUFLOW license as part of that. So you're not using up your standalone or your network license from your own system. The machines that we're accessing are fairly robust modeling machines. They're not supercomputers, but I think they're quite comparable to what most of us typically use to run our models in our offices. And again, the FloodCloud system can run a variety of engines. It is somewhat engine agnostic, and we're adding swim here shortly. So just to recap, some key benefits of using FloodCloud and of modeling on the cloud in general is it provides us quicker results. This is especially the case when you have more than one simulation running, because you can run numerous simulations at the same time. You can run these simulations in parallel, and so it might have taken days or weeks can now take just hours. You're able to run a greater, more expansive analysis, and so you're no longer restricted to just a couple of simulations. You can let your imagination run wild and run all sorts of scenarios and look at those results and see how that impacts your system. FloodCloud and the cloud computing with flood modeling is highly flexible. So if you're part of an organization where you have kind of cyclical computing demands, where one week you need a lot of computational power and the next week you don't, the cloud might be a good option for you because it allows you to ramp up and ramp down seamlessly, and really you pay for what you use. It's available 24/7 from anywhere you need it around the globe. FloodCloud is reliable and secure. It's backed up by Amazon, so it's less prone to many in-house IT challenges. Their uptime is high. And then lastly, I think the cloud is really cost-effective. So especially if you're one of those organizations that is only needing lots of computing power on an occasional basis, this is much cheaper than buying your own systems and then leaving them idle for large parts of the year. So it really can be a good solution for many organizations. And then I think the key benefit not listed here that I think is maybe most important is that it's really easy to use. The FloodCloud product makes cloud computing for flood modelers really simple. And that's what I want to show you here in these next slides is an example, a demonstration of how that works. But with FloodCloud and flood modeling on the cloud, there's definitely some items to consider. It's building models and debugging models is still a time-consuming exercise. The cloud doesn't really help with that. You have to think about all these simulations that you're going to develop, and there's a lot of work that goes into both creating those and then processing the information that comes out of them. So how do you use all these hundreds of simulations to make better decisions? How do you use those to make your models better? And so it takes some thought about how you want to do that. Depending on which engine and which software you're using, there are some tools out there that help with that process, but definitely something to think of. You also need to plan for managing huge volumes of data. So if you're running hundreds of simulations, you have lots of input, lots of output. You might need to think about being selective about which variables you save, maybe not save all the variables. Maybe you don't keep the full time series, you only keep the portions that you're most interested in. Another issue to consider is that you're typically required to use standard versions of software. So if you're using beta versions or have some productivity special add-ons that are developed just for your system, it's possible but harder to deploy those onto the cloud. And then lastly, there are still some organizations out there that restrict the use of cloud computing due to file security policies. And I think this is becoming less and less an issue because I think organizations are realizing that the cloud systems tend to be more reliable and more secure than most of our in-house systems. But there's still, again, are some organizations where that's an issue. So something to consider before you embark on a cloud computing project. So how do you use it? Well, like I said earlier, it's quite simple. You set up your simulations as you would normally using any of those engines we talked about, so HEC-RAS or TUFLOW or Flood Modeller. And then you start up the FloodCloud software application. You open up your project, your model project, and the plans you want to run, and then you select them and say run on the cloud. What then happens in the background is that FloodCloud takes all of the input data associated with your models, zips them into a file, uploads it to the cloud control server, distributes those various simulations amongst multiple processors, starts those simulations, provides real-time feedback to you as the user, and then when it's all finished, it downloads the results back to your local computer. So from your perspective, it's just as if all these things have ran on your own machine. It just happened a whole lot faster. You can then go and view and process those results just as if you would have run those on your own machine. So I want to show you how that actually works. Here I have a model I've built. This is a TUFLOW model. You'll notice here that I have multiple simulations that I've created. So this is more than just one simulation, but I've got my terrain and all my model components as part of this. So I go now to FloodCloud. Again, this is a standalone piece of software for multiple types of engines. You'll notice here that there's a add from file, so I can use this to find my modeling files. So I do that. I open up the model I just showed you. I add in all of those simulations that I showed you in the previous screens. Now, I can select just a couple of these and tick this run box and run a couple, or I can go all the way up and say select all and run all of them at the same time. So that's what I'm going to do here today. I'm going to run all of them. Now, it's a good idea before clicking go to test locally. What that means is it starts the simulations on your own machine just to make sure things run and all the files are there. A simulation that doesn't run on your computer probably won't run on the cloud. So it's just a good quick check, but I've done that already. So I'm going to go and push run selected. So once I do that, the window changes a bit. You'll notice that all of these windows pop up on the bottom. Each one of these windows is for a distinct separate simulation. And so that shows me the status of each of those simulations. So after waiting just a brief moment, it starts zipping up all those files, preparing to upload those inputs to the cloud. Then it starts uploading that information. This can take a little while, depending on how big your model is, depending on how big your terrain files are. So it is something to consider is the upload and download times. It is very much dependent on your bandwidth and internet speed. And then requests the resources on the cloud. So this is finding processors on the cloud and then sending those packets of information out to those processors. So another couple seconds while it waits for simulations to start. And then pretty quickly, you start running your simulations. You can see here, there's these progress bars. Those allow you as the user to understand the status of your simulations. And then in each of these windows down here, this is one for each simulation. You can look at the status of each of those simulations. You can go through a whole host of values. You can click on any one of these, and you can see graphically and numerically the status of your model from the standpoint of inflows and outflows and changes in volume. So it's really a helpful way to monitor the progress of the simulations. If for some reason there's a simulation that appears that that's not doing what you want it to do, and you can tell that from the diagnostic statistics, you can shut it down. You can turn off that simulation and not use up any more cloud credits for that simulation. So after a little while, these simulations have progressed. We're now about half complete. You can see here I'm looking at cumulative mass error. I like to keep track of that as an indicator of how the model is functioning. So this might be a case where I would consider stopping a model if that error was higher than I wanted it to be. So a lot you can do with those windows. You can see now that some of my simulations have completed. They have the 100% progress bar, and they start downloading automatically to my local computer. So I have one here that's completed downloading, a few that are starting. You can also see down in this box, I'm looking at the tabular output values, so I can monitor the results of that simulation. Now all my simulations are complete and they're downloaded back to my computer. So just like that, I ran, I think it's 17 simulations in the time that it would have taken me to run just about one. Here I have 4 of these that I'm really interested in, so I just selected those. I'm looking at the diagnostics for those 4 simulations only. But this gives you maybe a higher resolution version of these icons and what the FloodCloud interface looks like. There's one simulation where I wanted to check that cumulative mass error and investigate that further. So then I exit out of FloodCloud and I go back to, in this case, Flood Modeller. That's what I'm using to view my TUFLOW results. And here you can see my model results, this gridded data and vectored data. You can see all my simulations here on the left side. And so I can view those results just as I would have otherwise. I can post-process those. I can add those to my reports, make figures, etc., just as if I'd run those simulations on my computer. Another really neat part of FloodCloud that I really like is the job history. So your FloodCloud is linked to an account, and this keeps track of all the simulations associated with that account. And so if you share that account amongst a project team, you can use that as a project and task management tool. So you can keep track of what simulations have been completed, and you can keep track of who's doing what. You can go and find old simulations that you thought you might have lost. They still probably exist on the cloud, so you can go access those results again. There's really a lot you can do with it. You can also use it for billing. You'll see here that it has the number of credits used. And so if you want, you can use that and just transfer that cost straight on to the clients for whom you're performing this modeling. So it's a great way to keep track of the costs associated with the processing and the simulations for an individual project. So I now want to jump into a couple of case studies. This first one is a case study from the state of Texas in the United States for the Texas Department of Transportation. In this case, we're using HEC-RAS 2D. This was a situation where at the last minute, there were some major design changes and we needed to still keep the project on schedule. So we had 46 separate alternatives to evaluate, 5 different design flow events. The model took a long time to run. We have over 230 simulations that we were needing. And so this would have taken about 13 days of processing on 2 machines running simultaneously. But instead, we ran it on the cloud. And so instead of running 2 at a time, we ran 230 at a time, all in parallel, all at once. And then we had results from all of them in just a matter of hours, which really allowed us to meet our project schedule and gave us a little bit more time to actually analyze the results and see what it all meant. That's really the most important part. Another case study, this one is in Australia. This is for the Bayside Council, was using TUFLOW 2D. So again, with FloodCloud, it's somewhat engine or software agnostic, so we can use multiple different solvers within FloodCloud. In this case, we had a range of design flood events that we needed to simulate, so over 70 different simulations. This would have taken 11 days of processing time if we ran it on 2 machines simultaneously, but instead we could run all 70 at once in parallel. And so once again, it takes a matter of hours instead of days, which frees up a lot of time on that project for doing much higher value work. Another example, in this case from England, this is with the Environment Agency. In this case, we're using the Flood Modeller software. Similarly, we had multiple return periods. In this case, we were considering future climate. So we had 5 climate change scenarios, multiple management options for the pumping station, which resulted in about 100 simulations. This was a beast of a model. It took a long time to run just one of them. And so 100 of them would have taken 70 days of processing time. So over 2 months of processing on the machines that we had available to us. But instead, we could run them all on the cloud at the same time in parallel, have it done in a matter of about a day or 2. And that really freed up the project schedule substantially, provided huge benefits to the project. One of the things it did in this case is that with that extra time, we were able to look at additional scenarios that we wouldn't have otherwise had the time to look at. So we looked at the results from these first 100 simulations and realized there was some additional changes to the pumping station configuration that could optimize the system. And so we could simulate those and get those results and ultimately provide a higher value, better product for this project. So I see a couple of questions popping up in the question and answer, and I will have some time in a minute to answer those. But please, folks, do keep asking those. We get a couple of questions quite frequently, so I was going to go through those, and then I'll turn it over and we can answer any of the live questions within the webinar. So one of the questions we frequently get are, do you get the same answers using the cloud as you would on a local system? And the short answer is yes, you do. It's the same solver being run on both the cloud as your local system. It's the same input files, so you get the same results. And we've tested this. So we have run the same model in both the cloud and on a local system, compared the results, and they're identical. Is FloodCloud quicker? The answer is, it depends. For a single simulation, if you're doing just one, given that, and you're using a decently powerful machine in your office or at home, and you're using one of these cloud machines, the cloud actually might take a little bit longer because you have the upload and download time. But where you really see the time savings is when you're running multiple simulations. And so whereas otherwise you might have had to run those in series, you can now run them in parallel. And so that's really where you see the increase or the increase in speed and the time savings. So we were testing this at one point. We had 63 simulations in HEC-RAS. It would have taken 32 hours on a local PC, and it only took 4 hours in FloodCloud. So substantial time savings there. How much does it cost? Again, it is run through a credit system. You pay by the credit. So the equivalent cost is about $3.30 for a TUFLOW simulation hour and $2.60 for a HEC-RAS simulation hour. That TUFLOW simulation hour includes the license. The same thing can be said for Flood Modeller simulation hours, that it includes the license, so it frees up the licenses that you have locally. There are a variety of credit packages available. So you might get a $1,000 package, and that covers over 300 simulation hours in TUFLOW, or at 10 hours would cost about $33. So I think that's really quite economical. I think especially when you consider the cost of buying and maintaining IT infrastructure. I feel like we often in my office, we buy a couple of extra modeling machines, and we're always struggling to keep them up and running because they're being pounded by various users all the time. And so freeing up that IT maintenance is one huge benefit of using something like FloodCloud. And with that, I'd like to thank you all for your time and your attention and your questions. I'm looking forward to answering some more of your questions and discussion. By participating in this webinar, you are eligible to receive some free credits, so you can take FloodCloud for a try and see how it works for you. We also have some additional case studies and our new fact sheet at the website below. If you have questions afterwards, please feel free to reach out to the Flood Modeller team, which is it's the same as the FloodCloud team. You can contact me individually. My email is there. You can contact the Flood Modeller email address. Go to our website. Keep in touch with us on social media. There's a couple ways to do that. And with that, Trevor, I'm opening this up to questions and looking forward to some discussion.
What a fantastic presentation. Thanks very much, Tyler. I can see the questions coming through, and you were saying, yes, we've got some questions here. I'll take the frequently answered one. That's good. We did that. Let's get stuck into these questions right now, because they're piling in now. And we've got a good 25 minutes to go here. So let's get stuck into it. And just a reminder, everybody, along the chat line, you'll see today's webinar attendees are being offered by Jacobs FloodCloud credits, free credits. And there's an access point to that, on the access link to that, and also for contacting Jacobs, as Tyler said, plenty of information on the chat line for you there. All right, let's get cracking. Ryan,
starting at the top.
Ryan Wardley says, say again. I'll go for it.
Yeah, go ahead.
Ryan Wardley says, is there any similar product available for coastal models?
I'd probably you might need to be specific as to which coastal models you're talking about. I know that there are similar products out there. I know that, for instance, DHI and some of their coastal models, they offer something called software as a service, SaaS, and it runs the simulations on the cloud, similar to what FloodCloud is doing. The big difference is that it's not user-friendly in the same way. So when I've used it before, I've had to actually run it through staff at DHI. So I send my models to DHI. We have an account set up with them, and they run it for us, and they send us the results, and it's running on the cloud. I'm trying to think if there's other ones. There may be others, but that's the one I'm familiar with.
So Ryan just added to that, Delft 3D and Mike. You just see on that down arrow of the...
Yeah, so with Mike, with DHI, I think using their SaaS system would do that. I don't know about Delft.
Yep. Okay, we'll keep moving. Thanks, Ryan. That was a great question. Here we are with Dan Evans. Hi, Tyler. What are the implications of using cloud for data processing in terms of confidentiality, sensitive information? Are there controls in place to protect the data? You've probably just seen that question before.
Yeah, no, and it is a concern. I guess I would say that, yes, there are controls in place. Your data are linked to your account. Your account is password protected. So if you're not sharing your password, you're not sharing your account, and those simulations are secure. It's secure on the various cloud systems. So we're using Amazon Web Services. So I think that security is high. I'm not going to say it's foolproof. I keep, we always hear in the news stories of systems getting hacked. But I guess I would say I think it's more secure on this system than it is probably on most Office systems. So it's something to think about. But I think it's not a huge issue.
Yep. Thomas Liu says, what is the maximum number of parallel simulations allowed for each project?
I'm not going to say it's completely limitless, but it's really high. I know that we've had some where we've run hundreds at a time. I think thousands is feasible. It really has to do with how many credits you have. You want to make sure you stock up on credits before pushing go on 1,000 simulations. I think there's probably some other considerations to think of, mostly the, how do you create thousands of simulations and process the data? But, I think part of the application of this is Monte Carlo simulations, where you're running thousands of simulations and kind of randomly adjusting your input parameters. So yeah, nearly limitless. It's, I've not seen anybody hit a limit yet.
Yep. Yeah. No. Great question. For TUFLOW, David DeMoro has asked for TUFLOW, talking about HPC as a solution scheme, and with the GPU hardware command enabled, can your computers handle the combo, or does the model have to be run in Classic?
So the current system for TUFLOW is limited to just Classic, but we are in the process of enabling the HPC and the combo. So I think I'm not sure if it's weeks away or months away, but soon the HPC will be enabled on FloodCloud.
Yep, that's great. Yeah, thanks, David. Hang Baran has asked, based on the previous projects using FloodCloud, do you have the assessment results between FloodCloud and local run software? Is it more reliable and accurate?
Yeah, so we've done a number of benchmarking tests, and I think I'm understanding the question. So if I don't answer it directly, please kind of re-ask and let me know what else I can answer. But yeah, we've done benchmarking with the FloodCloud system, both in terms of speed on the FloodCloud and the accuracy of results. And so the results are identical. It's running the same simulations, the same code is running on these computers as would run on your machine. The time, it depends what system you're comparing it to. So, all of our computers have different specs. I showed earlier the specs for the cloud system that we're using. So for a single simulation, it might be faster, it might be slower, but I think it's the multiple simulations where it comes in handy. And I think actually it was some folks over at TUFLOW that were doing some benchmarking against FloodCloud and comparing it against a whole variety of machines. And FloodCloud stacked up right in the middle of the various machines they were testing in terms of speed for a single simulation.
Yeah, these are great questions. Thanks, keep them coming. That's excellent. Obviously, a lot of thinking going on out there. I've just got one, not a question so much as it would make a huge amount of sense not building your own computing equipment, but from and the outlay of that, of course. But in terms of the generational IT movement is quite high. You can be out of date within 2-3 years. Equipment. Yeah. So that must be surely a factor in all of this. Yeah.
Well, yeah. So I mean, you're not having to keep up your own systems. Right. You don't have to replace your computers every few years. Yep. Amazon's doing that. Microsoft is doing that, and you are able to stay kind of current in a much more cost-effective way than going out and spending $3,000 on hardware every few years.
Especially when you're talking about this sort of processing. We're not talking about word processing. We're talking about major, massive data processing. Yeah, for sure. Okay, let's move right on. Thomas Liu says the credits are calculated based on model simulation hours. Then does the model time step settings affect the cloud computing cost?
The model time step settings, to the extent that they impact the run times, that's the only way that they're impacting your costs. So if your time step settings, so for instance, if you lengthen your time step and you're running a shorter simulation, it takes fewer simulation hours, then it would be cheaper. And vice versa, if you shorten your modeling computation step, it might take your simulation longer. You know, of course, then, as all the modelers on the line know, you have this balance of stability versus your computational time step, and so there's some sweet spot there. So if you're using a time step that's too long and your model crashes, if it crashes at the given time step on your machine, it's going to crash on the cloud, and then you kind of get garbage back. So you still have to kind of play that game of finding that sweet spot in the simulation time step to optimize how long it takes to simulate, and thus how expensive it is, how many credits it takes to run, versus the kind of results you're looking for, and maintaining your model stability.
Yep, that's great, Thomas. So thanks for that. Michael Brezel has said, I may have misheard. How does licensing work with TUFLOW? Does it use a cloud license or the standalone license?
Yeah. So once you hit run to cloud, using FloodCloud. So let's say, in the example I gave, we built a TUFLOW model. I I opened it into FloodCloud, and I pushed run on the cloud. And then happening, it's not using any of my my credits, or sorry, my TUFLOW licenses at my office. So whether or not I have a standalone or a network license, it's not using any of those, because the simulations are being performed on the cloud using the cloud license. So that's where it frees up your network license or your standalone license, because it's not using it while it's running those simulations.
Thanks, Michael. John Single, does FloodCloud allow you to use the scenario and event capabilities of TUFLOW? That is, within one control file, you're able to batch multiple runs from a single control file. Or do you need to produce individual control files for each scenario that you wish to run? Get that?
That is a good question, and I'm not sure I have the answer to that. I would have to look into that. I don't know the answer to that. And so actually, if you can email me, I would be happy to look into that and get back to you.
Yep, no, really good.
Yeah.
We're just about hit the full bottle with our questions. The thing about contacting Tyler is that we've got all the details on the chat line there. You can see for FloodCloud credits, today's attendees, webinar attendees, and there's a link there for that, and also to contact Jacobs and for all information about FloodCloud modeling. So follow up the chat line. That'd be fantastic. Well, I think that's hit the mark today, Tyler. Thanks so much for your time and effort and the energy and the after hours on this. It's been a really good discussion. Thanks so much.
Well, thank you so much for having me. I really enjoyed it. I enjoy this type of conversation, and it's my pleasure. So, Trevor and Australian Water School, thanks for hosting. You've got a good series you run here.
Fantastic to be able to do it. I see the feedback on the screen there. That'll come up in a moment. The recording that will come to everybody. We'll email it to everybody, and please do look on our website for the webinars and online courses, as you can see on the screen there. Well, that's it for today. Thanks so much again, everyone, for joining us, and thank you so much, Tyler, for being part of this webinar. It's been great. See you all next time. Bye for now. Subscribe to this YouTube channel by clicking the subscription button. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.